All right, welcome to your first lecture video by me of the semester. We're going to start with Chapter 2. Hopefully by now you've all seen Dr. Kozatek's video for Chapter 1. I wanted to show that one because it's solid and she says exactly the same things I would. So, but from here on out I think I have a slightly different take on how to explain things. So all the rest of the videos will be by yours truly. So all of our material comes from the Revell textbook for introductory chemistry. So through Macmillan Learning, which is the same company that your homework platform is through. So all of this stuff tracks right along with your homework. Now hopefully you've also picked up a workbook packet, worksheet packet. And the first section of that packet is all what are called clicker worksheets, and those are designed to go along with these slides. So those are going to be collected at exam time and graded just for completion. Since you need to watch the videos anyway, the best thing that you can do is get that worksheet out and just follow along with the video and fill in the spaces on the worksheet. Okay, and it's exactly what you would do if you were sitting in my classroom as well. So you would all get a worksheet and fill them out as we went through the lecture. Okay, so let's get started. Now in chemistry, we often deal with numbers that are either extremely large or extremely small. And since sometimes we're dealing with, as many as like 20 zeros, either before or after a number, that becomes completely impractical to write down and do anything with in your calculator. So what we do is we convert those large and small numbers into a more usable fashion, and that's what's called scientific notation. Okay, so you always have a coefficient, which is this guy right here. Whoops, that's the eraser. So the first number is what's referred to as the coefficient, and then you have a multiplier, so that's the times 10 part, and then your exponent tells us how many times to either multiply or divide by 10. Okay, so let's look at like an example of how that works out. So if I say 2 times 10 to the 1, okay, that means that I multiply by 10 one time. So 2 times 10 is 20, right? So if I say 2 times 10 to the 2, that's the same thing as saying 2 times 10 times 10, or 2 times 100, so 200. So if I say 2 times 10 to the 3, 2 times 10 times 10 times 10, 10 times 10 times 10 is 1,000, so that's the same thing as saying 2,000. Okay, so our exponent tells us how many times we use the 10. Now you don't generally have to write out this times 10 times 10 times 10 thing, but that's just for demonstration on how this works. Now if the exponent is negative, I actually divide by 10 that many times, okay? But you don't really have to worry about doing that math. Okay, I'll show you how to deal with these things without having to actually do math. Okay, so what we want to do first is to be able to convert numbers to scientific notation. Okay, and I'm going to warn you, my handwriting is not awesome, but it is generally legible. So hopefully, if you can't read it, you can at least understand what I've written out of context. Okay, so when we convert numbers to scientific notation, the first step is to put the decimal place after the first non-zero digit. Okay, now if you have big numbers, a big number will get a positive exponent. And small numbers will get a negative exponent. Okay, so let's take a look at an example of that. So if I have a number that looks like 2.79 times 10 to the minus 5. Okay, so what I'm going to do is, excuse me, I'm getting ahead of myself in my notes. Let me try again here. That was going the wrong direction. So the correct number I want to use for my example is 54,200. Okay, so it's a big number. So it's going to be a positive exponent. Okay, so let's figure out how to figure out what that exponent should be. So I'm going to take and put my decimal place after the first non-zero digit. So it's going to go right there. Okay, so we're going to say that we're bringing the decimal place from the end of the number. So I've moved that decimal place now 1, 2, 3, 4 places. Okay, so that tells me what my exponent is. So this number in scientific notation, 5.42 times 10 to the 4. Okay, a positive exponent for a big number. And I've moved the decimal place 4 places. So that tells me what my exponent is. All right, so let's say I have a number that is 0.00942. 942. Apparently I'm fond of 4 2s today. So small number gives us a negative exponent. Okay, so I'm going to take and put my decimal place after the first non-zero digit. So it's going to go right there after the 9. Okay, now I'm going to count how many places I've moved my decimal place. 1, 2, 3. Right? So this number in correct scientific notation should be 9.42 times 10 to the minus 3. Okay. Now if it helps to think in terms of left and right, did I move the decimal place left? Did I move it right? That's a fine way to think about it as well. I've always been pretty good at keeping in mind that small numbers get a negative exponent, big numbers get a positive exponent. All right, now, if I want to go the other direction, so let's say if we want to convert to standard notation. Standard. Okay, from scientific to standard. Okay. If the exponent is negative, we move the decimal place left. Okay. Again, we're going to take our scientific number and we're going to make it into a small number. All right, so conversely, if the exponent is positive, we move right. We're going to take our scientific number and we're going to make it a big number. All right, so if my number is 2.79 times 10 to the minus 5, right? So it's a negative exponent, so I'm going to move left. All right, so I'm going to take my decimal place and go 5 places to the left to make it a small number. 1, 2, 3, 4, 5. So I'm going to put my decimal place right here, and I'm going to fill in the gaps with zeros. All right, so this number from scientific to standard should read out to be 0.0000279. Looks like I'm running out of room here a little bit. If I go from, let's do another one where we go the other direction. So if I have 6.443 times 10 to the 6, I'm going to make this a big number by moving the decimal place right. Right, so easiest if I write it down here without the multiplier. So I'm going to take and make this into a big number by moving my decimal place right 6 places. 1, 2, 3, 4, 5, 6. So my decimal place is going to end there. I'm going to fill in the gaps with zeros. So this one reported to, in standard notation, would be 6,443,000. Okay, so here's your first crack at it yourself. So the way this, I would like you to use these videos is when we come across one of these problems like this, where it says to do a thing, I would like you to pause the video, work out the problem yourself as best you can, and then press play again, and then I'll work through it with you. So give us a pause, and we'll be back in a second. Okay, so I'm assuming that you worked it out yourself in the last few minutes, so let's talk about how to go through this problem. All right, so I want to convert from standard to scientific. So I've got 1,300,000. All right, nice big number, so it's going to be a positive exponent. I'm going to put my decimal place after the first non-zero digit, so it's going to go right here. And then I count how many places I just moved the decimal place. So 1, 2, 3, 4, 5, 6. So this number in scientific notation should read 1.3 times 10 to the 6. Positive exponent for a big number. All right, give us a pause, work it out yourself, and we'll come back. Okay, so 0.0053. I'm going to take and put my decimal place after the first non-zero digit. It's a small number less than 0, so small number, it's going to be a negative exponent. All right, so let's place our decimal and then count how many spots we moved. We went 1, 2, 3. So this number in scientific notation, 5.3 times 10 to the minus 3. And according to the slides, we have the correct answers. Good for us. All right. Here's your next pause. Work this one out for yourself. Okay, so we have 2.3 times 10 to the minus 3. So it's a negative exponent. Means it's going to be a small number. All right, so I'm going to take and move my decimal place to the left in order to make this a small number. So it tells me to move 3 places. So I'm going to go 1, 2, 3. I'm going to put my decimal place right here and fill in the zeros. So this number in standard notation should be 0.0023. Give us a pause. All right, 1.54 times 10 to the 4. So we have a positive exponent. So that means it's going to be a big number. So I'm going to move my decimal place to the right in order to make it a large number. And the exponent tells us 4 spots. So I'm going to take and move my decimal place 4 places to the right. 1, 2, 3, and 4. Fill in the zeros. So this number in standard notation should be 15400, or 15,400. And look at us. We're correct again, aren't we good? Ta-da! Right now, you are going to need to do this in a calculator, okay? So there are much, much better ways than actually typing in times 10 and trying to do an exponent, okay? Much, much better ways. And those better ways involve the EE or exponent button, okay? So some calculators have a designated EE button, like the one in the image here. Others have the EE above one of the other buttons. Okay, and in order to use those things that are above the other buttons, you have to use the second button. Okay, and usually the second button is the same color as the things that are above your regular buttons. Okay, so the EE takes the place of the times 10. Okay, so let's work this first problem sort of together. So if you're using your EE button correctly, the way this should look in your calculator is that it should read 4.5 E2, which means 4.5 times 10 to the 2, and 2.3 E to the minus 8. And you want to make sure to use the actual negative sign, not the subtraction button, but the negative sign. You also want to make sure to use parentheses. Okay, because your calculator needs to know that this is one whole number and this is one whole number. Okay, if you don't use your parentheses, the calculator just sort of runs through it like a sentence. Okay, and we don't want it to do that. Right, so if you've done this, entered this information correctly, you should get an answer that is 1.0 times 10 to the minus 5. Okay, now if you're not actually seeing this, okay, so if your calculator spat out, I think that's right, 1, 2, 3, 4, this, you need to switch modes. Okay, because you want to be able to report that answer in scientific notation. Okay, because sometimes your sapling homework and various things are going to require that. Right now, you got to listen to my words because I can't really show very well how to do this, but I can actually, if I look at it. Let's see. So looking at this image right here, you see this little guy right here, that SCI, that's how you change from standard notation in your calculator to scientific notation. So it will actually show you numbers in scientific notation. Okay, so in order to use that, you'll hit the second button, and then you'll hit the number 6, this SCI button. Now your calculator, depending on the model that you have, it's going to be in a different place, but they all have that SCI somewhere on the keyboard. Okay, so you'll need to be able to switch into scientific mode if you want to. Now the other thing that you can do is, if you want to get out of scientific mode, you see this FLO, right? That will take you back to standard notation, all right? So if your calculator shows you this one with all the zeros, hit the second SCI button and it should show you this, okay, in scientific notation. All right, but it's very, very useful to be able to go back and forth between standard and scientific. All right, now 4B. I'm going to let you work on this, give us a pause, and we'll come back. Now, if you've entered this into your calculator like this, E12 divided by 3.03 E negative 14, Hopefully you got an answer back in scientific notation because we switched modes into scientific. 5.08 times 10 to the 25. Right, now, it's common to be resistant to using scientific notation in your calculator, right? But there's a limit to how many digits you can put in there, right? It's not going to let you put 12 or 14 zeros and try to enter this number without scientific notation. And conversely, getting the answer back with 25 digits, your calculator's not going to be able to show you that, okay? And during the course of this semester, we will readily deal with numbers that are this big, okay? So even if it's painful, even if it's frustrating, get your head wrapped around scientific notation and how to use it and how to do it in your calculator. It's very, very important. Okay, looks like we have the correct answer. Thank you, slides. All right, question 5. All right, which of these is the largest value? Okay, so we can say right away, we can take a look, and look, we have a negative exponent and a negative exponent. Okay, those are going to be very small numbers. All right, so definitely not on the in the running for being the largest value. So we can immediately cancel out those possibilities. All right, now let's take a look at answer B. If I were to convert that to standard notation, that comes out to be 1.7800, not 1.78, 17800, or 17,800. All right, it looks like 100,000 is definitely larger than that. And poor number 38, not even in the running. Poor guy's got to go home, cry himself to sleep. Fair warning, I'm corny and I'm cheesy and I like dad jokes. So you're going to have to hear them a little bit throughout the semester, and I'm sorry. All right, give us a pause. Go ahead and work this one out for yourself. Okay, so if you entered this in your calculator, which you should have, you would have 3.52 e to the 3 times, and using your parentheses, 2.33 e to the 8. And hopefully your calculator spat back at you, or that's not very polite of your calculator, gave you the correct answer in scientific notation of 8.20 times 10 to the 11. Answer is A. All right, give this one a workout. All right, so we have 8.02 E8 divided by 2.33 E negative 4. And we should get as a result 3.44 times 10 to the 12. The answer being C. So again, I just want to reiterate, if you're having trouble getting the correct answers, having trouble entering the information and getting the right number back, that's a perfect thing to ask about during one of our morning Zoom meetings. All right, and with that, we are going to stop with this particular video. I'm trying to keep my videos from being too long individually. So we're going to cut this one off, take a breather, walk around, get a drink, and then if you're feeling up to it, come back for video number 2, and we'll pick up right where we have left off.